now. Okay, then welcome to another issue of ZK Ask the Expert. Today we talk about performance tips. I'm quite happy that so many people joined today or signed up. I think it was about 70 people signing up, and already 32 have joined. It's a good percentage. I'm Robert, as not always, but as in most of the recent times. I'm a consultant at ZK since 6 years. Also support engineer dealing with everyday questions. And yeah, today, as I said, we talk about performance tips. Performance tips, one of my favorite topics. I can talk about this for ages, I think. So I'll try to focus on what's most important. And as always with performance, before I can give you any tip, we need to figure out what is slow. My first item in the list. Before we apply any kind of performance tuning, we need to figure out if something is slow or what is slow, or at least check what we can expect from our application. So for this, I think at least 5 years ago, I created this kind of flow chart. I'll just open the link. Hope it. No, I didn't create flowchart. I created the the logic behind, and my colleague put this into a chart that looks a bit nicer. And we will just go through the stages of what are mostly or where to look for performance bottlenecks in your application, and then we can see how we can debug this, which tools we can use, and so on. So from my experience, whenever I deal with a ZK application, this might be ZK specific, because ZK has a client and server side part, we first need to figure out where something is slow. So in most cases, you have your application, you click a button, or you try to load a page, and it just takes longer than you expect. And then you need to just figure out where the problem is, at your client side, at your server side, or at the network side. And this is quite an early decision you can make when looking into your browser developer tools, so you can identify whether something is whether there's a network request running for a long time. If the request responding very quickly, then you most likely have a client-side issue, and you start debugging in your browser or start profiling in your browser. Obviously, if you see that there are long-running requests and it's just a static resource, then the server is most likely not having problems serving static resources. So it's maybe a networking issue, which you can which you can address with your infrastructure team. There's rarely something we can do from a ZK perspective to fix network issues, because that's somehow out of the scope of a framework that deals with the front end. It's not an infrastructure framework. But if, however, there's a long-running request, there can be many things happening many things can be inferred from the timings in the request. I will show this in a second, what this looks like in a browser, if you haven't looked at this before. But the request is, oh no, I just show it. It's easier to look at something. If we check the network tab, we just go to our, need to start the server first, okay. We go to our simple page. This is already advanced. So we go to the, did I call it simple or basic? I think basic problems. So we just load a page, and then we have the network tab open as opened here. We can filter what we're interested in, and on a ZK application, the most interesting bits are the document requests and the XHR requests. We can check everything, so you can see what else is downloaded. So if we re-download again, we see every resource that the page is loading. And we see a larger request, a larger resource like here. It's 2.4 megabytes. It's this large because I disabled the minification of JavaScript code. And here we can see the breakdown of the request. And we can see some kind of when the request was started and the waiting time, how long it was waiting for the first byte and how long the download actually took. Now, these are the infrastructure issues where we can't really help. If the content download takes long, then it's most often just a slow connection. Or if it takes a long time before the request starts, then it's maybe just a connection issue trying to figure out all the paths through all the routers and proxies. Yeah. And in this case, the waiting time is the time that's spent on the server side. So here we see 17.93 milliseconds, which is quite good. It's not a long time that the server actually took to produce the first byte that is sent down to the client. So this is the network tab. There's a few more details you can add. For example, the use large request rows. It gives a breakdown of the uncompressed and the compressed size of a file. If compression is enabled here, for the resources, it's disabled. So that's why they are roughly the same size. So just go back to the chart. I think it's in the browser here. So that's what we see. There could be, in rare cases, the sending takes a long time. Now, maybe if you have an AJAX request and it contains lots of commands or lots of data that's sent from this client to the server, if this is quite rare. If there's really a big request, then we need to figure out where the clients or where in the client side this data is gathered and why it was accumulating maybe too many requests. Could be an incorrect setting of an event to ignore duplicates. If you have click events that only should send once, even if you click twice, it can be configured to or certain events can be configured to ignore duplicates. Mostly with scroll events, when you're only interested in the last scrolling position at server side, for example, then you just, especially with smooth scrolling, it's easy to accumulate hundreds of on-scroll events if you don't ignore the duplicates of those. So this would be a client-side issue. Connecting, as I said, network issue. If the connection or the stalling or whatever, the handshaking takes a long time, also nothing also not a lot I'm talking about today. The waiting time is the most interesting part, where we can see what we can profile at server side and where we can do most in ZK, and also client side. If there's no long running requests, if there's some JavaScript running that takes a long time, that's also something I will focus on today. And then again, receiving, if there's a big response, and if the response is bigger than you expect, then check your server if you are sending too much data or if you're creating more components than you expect, or maybe ZK is creating more components than you expect. There are some switches I will talk about how this can be controlled. But in most cases, this boils down to if you create less components, ZK will send less components down to the client side. And if the response is not big, it just takes a long time, then it's, again, bandwidth issue, not much we can do from a ZK perspective. So that's roughly my breakdown. And depending on what we see in the browser, we can decide where to start debugging or profiling. Before this, if it just takes a long time, you don't know a lot. So let's start with a simple example to just see what these different scenarios look like. As mentioned before, I'm interested in the document to see if the document is slow and the AJAX requests. For this purpose, I didn't enable WebSockets because WebSockets have less timing information. And because WebSocket is just the transportation channel, it doesn't matter how the data is transported. If it's generated slow at server side, it's good to have all the information available, or if it's a lot that needs to be processed as client side, then also it doesn't make a big difference, especially on local host. Everything is usually fast. So for this test, I created these 5 buttons just to identify different scenarios. So all these buttons are somewhat slow. For example, if they click the first button, we wait, processing, and then it's done. And based on the network request, we can make some guesses about where we should start profiling. So what we see in this case, we see nothing. Oh, we see something clearly here. The server side, the waiting for the first byte took 3 seconds. So most of our waiting time or 3 seconds happens somewhere at server side. So that's the, I would say, ideal image of a server side performance issue. Now, if I click a different button, it also takes a few seconds, and then it will do something. Now it's done. So what happened here? You can also look into the timings here. We can see the time to first byte was really quick. Yeah, the content download was really quick. These are milliseconds, not seconds. Huh? So there's even microseconds notified here. So it's something that was really, really fast. It just took, again, a long time. So it's not a network issue, and it's nothing that happens at server side. So it must be something at client side. We will find out how we get to this point. The next button does something similar. I click it, but we don't see any request for a while. And then suddenly there's a request. And again, the request is very quick, only a few milliseconds, but it took a long time before the request started. So it must be some kind of client-side code that happens before the request. Also, we will look into the profile if we can identify this. I'm altogether is some kind of mixed case where there's a delay before the request at server side and after the request, just to give an image of this. So what we can see here is the server takes 1 second, and there's some delay before and after the request. And then the last one, which is often a false negative that we sometimes get as performance issues, is someone clicks a button and is waiting. And says, "Oh, my system is very, very slow." And in these scenarios, sometimes if it really doesn't stop, a look into the console will often tell you there's a JavaScript error. So in many cases, not in many, in some cases, if you think the processing doesn't finish, because this is just an animated GIF, it will just run forever. It doesn't take any CPU from the JavaScript point of view. Sometimes it's just broken, and then the console will tell you about JavaScript errors. If the server side breaks, you will get an error message, but in this case, I made the response deliberately so that it doesn't pop up any error messages. To illustrate, sometimes you have to look manually into the console or ask your users to look into the console if they are somehow skilled enough to open the developer tools and have a look. Very often, this is a better information than just saying the application takes forever. Okay, so just have a quick look at the code of this. No, we just reload the page and do the performance tracing of these buttons. For this, Chrome and other browsers have a profiling view. I just clear it because I had some previous recording. And I just start recording, click a button, wait until it's finished, and then I stop it. And then I get this kind of overview telling me what happened here. And what we can see is, in this case, we knew there was a 3-second network request. So we can see here, there's a long network request in this recording time. And after this, there's a tiny bit of JavaScript code that displayed our notification. And then a typical pattern is like this, where we see the animation, where the animation is fading in. You see this fading in. One cool feature is that Chrome is capturing the screenshots of every frame during your during the profiling, so you can see perfectly when the processing finished and where the fading in started. So somewhere in between here, something updated the UI. And here we see some JavaScript code with all the details, what happens, do animation, and we expect this. And somewhere we see the notification call here, notification show. If we're interested in the code, we can directly go there. And then it goes into the show function, and then it tells us what went on in this method. So here, clearly, server-side issue. We would have to debug at server-side to figure out where the 3 seconds are wasted. With the client side, we'll just do both at the same time. We just clear again and record the client-side issue number 1. And then the client-side issue number 2. And then we can compare what the profile looks like. I made it, in this example, made it up very clear where the problem happens. So you will see very nicely that there's some code going on. Yeah, so when you see these kind of yellow bars, don't pin me down on the color. Chrome changes the colors from time to time, but the yellow bar usually means a JavaScript execution. And here we have a heavy JavaScript call, and you can see lots of tiny calls to something garbage collecting. Yeah, because I'm creating, in this case, I'm creating lots of date objects. We can just go there and see what the code does. Somewhere we have the code, global eval, JavaScript on response, ready, anonymous. See if we can find the function execute script. So here we see some JavaScript was executed, and in the previous response, we should see the JavaScript. In the response here, we see I'm iterating through 2 million objects and create date objects. So that's why the garbage collector is busy and creating 2 or 20 million date objects and clearing them up. So that's wasting the time, 5 seconds just creating objects, throwing them away. And then you have these kind of long running JavaScript calls. You also see nice timing information here, 5.8 seconds. Then again, the animation, which always looks like this scattered, lots of tiny updates of changing transparency of the animation. And in the second part, we see that that the long JavaScript happened before the network request. We should have a tiny network request here. Yeah, here is the network request. It was very quick. And before the network request was sent, there is this long function. You can also see there is a do click method causing this, or doing this, executing this code. Here we see there's a button, it has a click listener, and again the same code doing 20 million operations, or 20 million date objects. Wait, F12, didn't want to close the developer tools. And the third button, I'm all together, we just see everything in a sequence. And come on, processing for 1 second, then closing the processing and done. Stop. Yeah, here we see the gap of the network request in the middle, and 2 times JavaScript before and after. And I have a few cases of real life ZK examples to show what this looks like in a more advanced example. But basically, you see a JavaScript block, and if the block is longer than you expect, I would say 3 seconds is quite a lot for this tiny amount of work that has been done effectively. So in this case, I would say, why? Maybe we don't need this click listener. We don't need this extra code around it. And if we, at the same time, look at the server side, we just check what the server side is. No, we don't check. We will profile later in a second. What can we do? What can we do? And this one, obviously, was just an error, so not a performance issue. Let me check my training notes here. So demonstrate a few available tools in the browser in Chrome, Firefox. And Firefox has similar tools, but I still prefer the developer tools of Chrome just because I'm more used to them and I can read them more easily. Firefox, of course, is, I think, a bit more advanced on the CSS side, and Chrome is a bit more advanced on the JavaScript side. But if you need to debug or profile Firefox, of course, you can't use Chrome for this. So now the real, just go to the real life example, because this is also a client-side issue. We had this issue with ZK 4309. It takes a while to load because I'm deliberately creating a large amount of components which had a side effect in a second stage. So this one is expected to take long because it's just creating a lot. This one is a grid with 50 columns and lots of rows, just adding stuff to the page to make it busy. And then there was a performance bug when creating components, or when just creating labels on the page root level around it. Right now it's fast because I have the wrong version. I need to revert to an older version, and maybe that's a good time to just introduce the project slightly. As always, I use some kind of a local Jetty to run a simple project based on Maven. Not a lot of code, no Spring, no complicated things around it. I usually try to use the latest version. So here we see the latest version of Jetty just a few days ago, and ZK901, which was released yesterday, just to see that the fix also has an effect. So I'll just re-import the Maven project. Somehow, since a few Eclipse, since a few IntelliJ versions, the auto import of project doesn't work anymore. Maybe I broke something. So now it's switched to version 9.0, and then we just restart the server. Oh, time. Okay, 20 minutes. Okay, I need to go to some detail. Okay, server is restarted. So if we now reload the page, it should take similarly long as before, but the button we are pressing takes a long time. Just to give you an example of something where there's a ZK bug that shows an obvious problem. So if I start recording and I click this button to add 50 labels just below the screen, it takes a long time in showing some kind of typical behavior of something that goes wrong. You see lots of red triangles here, and also at the top in the overview, you can see that there's something bad going on. And here you see there's a fire sized and its real visible calls are somehow every time forcing a layout, and it's layouting the whole screen. 50 times it's layouting the whole table with all the cells. And this is far from ideal, and that's why it takes 3.77 seconds just to add these 50 text labels at the bottom. And this has been just fixed in ZK901. This already contains some workarounds which are quick, so there is a chance to do the same thing just quicker. It's just a special case where this caused an issue. But watch out, if you see lots of these red triangles, this might be something going wrong. If somehow too many, I don't know, if some of the code resizing DOM elements and at the same time changing styles causes CSS reflows. That's one of the very common CSS issues to watch out for. And this is often a case where you can report something like this to us, give us an example that shows these kind of behaviors. Sometimes it's not fixable. Sometimes it is fixable. In this case, it was possible to fix. So if we switch back to 901, we should have the fix included. And that's one of my first performance tips that you can do in every live. Try to stay up to date with ZK if that's possible, because performance fixes usually go into the later version. But also if there are regressions, there might be new performance issues, but we need to find them and fix them in the next version. Well, there's one question. Performance update. Okay, someone telling me about the Maven update. Okay. Maybe I'll try this later. Okay. Yes, by the way, I also use the latest version of IntelliJ. It's somehow updated yesterday. So if something goes wrong, we will see. So 901, still not updating. So re-import. Whenever you change something in the Pong, appears a pop-up to force update. Constant automatic reloading had some issues, so they made that change. So which is the pop-up? Okay, thanks for the tip. I will maybe you have some link to the issue, then I can look into this in detail. So just reload again, and now we can do another performance profile. I'll need to restart. And reload. And now it's quick again. We just record this for a second, add components and stop. And now we see, we check again when does the components, when do the components appear? Here, somewhere here. So here we see no longer an annoyingly large JavaScript block, just one call to real visible, one layout. So that's expected, and 188 milliseconds is maybe not 100% perfect, but at least not 50 times the amount. So that's what it's doing. So it's a big improvement from a linear to a more I don't know, constant time, or some better performance scaling. Okay, and also that's how we post our bugs. So if, for example, in this case, I posted this issue in our tracker with a similar way. I just posted these kind of performance traces and provided the example, and then compared the workaround to the problem case, just illustrating there are these reflows that can be avoided by applying a workaround. So maybe the workaround can be the default case in how ZK behaves. In this case, it was possible. Hopefully didn't break anything else. So that's this case. Then back to our performance case, performance problem at server side. We had these 3 seconds waiting time. How do we find out where our time is wasted? Sometimes I hear a question like, "Oh, I check my database," or I check my network connection, yeah, and these kind of general things. But it's very often too specific. Maybe sometimes you know exactly it's your database, but very often you don't know, and then you need to do some kind of profiling at server side. The simplest thing you can do is, if something takes long, if something takes 3 seconds, just hit the break button of the application and see if maybe the thread stops at the position that is the slow part. Sometimes this just works. Yeah, there's a useful pause program button where you can stop all the threads, and maybe we find where it's currently stuck. So we go back to the busy basic problems. It was the first button, yeah, which had the server-side issue. I have 3 seconds to click the pause button. Start, 1, 2, stop. So, and now we should be in the debugger. And unfortunately, there are multiple threads in an application, but one of them is maybe the one that goes somewhere into my code. No, not this one. This one looks like a connector, and maybe some HTTP request that's coming into my application. And if I go down the stack trace, no, there is none here. Sometimes you find it, not this one. I'll just go quickly through all of them. No. Frames are not available. Thread 12 running. Receive synchronized. Okay, I don't see it. So I was not lucky in this case. But sometimes this just stops somewhere that gives you a hint. Oh, there's too many. There's many more. Squad, scheduler, pool. I think it's wait nanos, get task, wait take. Okay, didn't help in this case. So if you're not lucky, sometimes you find the thread. Somehow in this case, I have too many threads. I don't know which one I should look at. And we will just do the start a profiler. What I do is I start Programming Visual VM. This is the cheapest tool or freely available tool. I just found it's still maintained, even though it's no longer contained by default in the JDK. There was just a new version a few weeks ago, so this one is still good enough for simple tests. I think there's more advanced tools that give you better insight, but they are often commercial and oh, it doesn't work. Come on, let me. I'm still in a breakpoint. Sorry. Just let this run. And in order to do some probing, I often just say, okay, let's open the performance sampler and I enable the CPU sampling, and then we can see if something is busy somewhere. Give me the browser again. Just make it a bit smaller. This time we don't need the client-side debugger anymore. Just click the button at the same time and click the I'm slow. In this case, we see there's one new thread appearing, and inside the thread we see a deep stack trace. So let's just look a bit more into the detail. And we can see it's going into some bean shell code. So bean shell usually means there is some code embedded inside your Zool file. So in this case, you would have to check if you have some bean shell running in production environments. We recommend disabling bean shell anyway, because and here it doesn't give me any more detail anyway, because we know our page. So if you see bean shell that's long running, just disable it, and then it will fail at the right place where the bean shell is no longer allowed in the page. But we can see it's a ZK application. It's somewhere during a page parsing and rendering. And if we look into the code, we should see our simple example. Oh, there's too many classes I don't care about. Close all to the right. And we just look into the basic problems. And here we have our client-side server-side button, which is just waiting for 3 seconds. That's why I didn't have a proper stack trace, because it's bean shell code. So don't do this inline stuff in real life. It's hard to debug, hard to trace. One performance tip: avoid inline on-click listeners. Implement them in Java code, and then you have much better places to put breakpoints. Okay, so that is this tool. Let's see the training notes. What else do I have to mention here? How much time? Oh, 35. Yes, so Visual VM is still available. It's I use it most of the time to take memory dumps, to do this kind of profiling to see where the stack trace is. If this was a long-running database request, you would see some kind of waiting socket for a database response, most likely in the stack trace instead of a bean shell interpreter. Another tool for memory. What does high mean? I wonder why I wrote this high here. I have no idea. And the Eclipse memory analyzer is also a free tool. So Visual VM and Eclipse memory analyzer. I use them depending on what I look at. Visual VM is good for smaller applications. If you have a bigger memory or heap dump, this one, the Eclipse memory analyzer, has a much better performance calculating the retained heap sizes of objects. Something we can look at in a moment. No, right now. Just look into it right now. So I have a few more examples that show how these tools can work. For example, there's the long busy running Zool file. Just look into the code directly. So here I have a real composer, and the composer will have some real Java code. Or we have the long waiting, which will just wait for 10 seconds. Long busy will just do something busy for 10 seconds. And a high memory composer, which will just show some significant memory consumption. which I would say stands for, it can also stand for lots of components that ZK creates. Whenever you just think there's a memory leak, how to find out where the memory leak is, some of these tools can help. So start with the waiting case again. If we open the waiting case, so I'll just close the links, break down, and long waiting. You see the page is just rendering for a long time. This case, I didn't use an AJAX request. I used just a long page loading that I can do after compose. So what does it look like in the profile? Again, we just say stop and restart the CPU profiling again, and then we just load the page again. We see our thread is opening, and this time we get a proper stack trace down to our composer, which is just waiting. And here we see even it's calling sleep, or it can be a socket wait or something else. So here we see quite easily a long stack trace and exactly where the problem happens. And I can also look into these hotspots is one thing to enable, which is more helpful in a long busy case. So if we open just stop again, clear CPU, and we go into the busy example where it's really doing something for 10 seconds. Did I do this now? Did this run? Is it loading or not? I forgot. Okay, now we see the thread starts, and you see instantly inside the hotspots, the method that is just in a busy loop will instantly show up. And because I made it very clear, 10 seconds is a very large time in a single method where things happen, but it will show a nice place where most of the time is spent. Here you see, of course, most of the time, a socket is waiting for some kind of request, which is also happening in a server. But you can always filter and say, I only want to see my code, ZK example. Or if you don't know where to find, maybe you just want to see zcos, ZK components, org.zcos, only ZK classes. And here you see right now ZK is not busy at all in this case. So it's some way of identifying hotspots very quickly. And then we have the case where we need memory. We just open the high memory case. No, we first start the memory sampling, and just open this case, and we should see a spike here. Do we see something? All right, in ZK, when there are no, this was the wrong case. I need to stop. I want a heap dump and then check where the memory is. So I take a heap dump of the current running application. And in ZK, if you suspect ZK to have a memory problem, or where your memory is stored inside your ZK classes or in your ZK application, you can take a heap dump, then go to objects, and every browser page corresponds to a desktop. So you usually search for desktop impl, and then you find there's one instance. So the number of desktops corresponds to the browser tabs I have currently open. So that is what I expect. And this is the stuff, the retained heap, that's what takes a while, but it will tell you how much memory this desktop impl is preventing from being garbage collected right now, because it's a live object. So in this moment, in this time, it takes 10 megabytes. So if you expect to have 10 megabytes in your desktop, then that's okay. If not, you need to check where the data is spent, and then you can go down the rabbit hole and see where your data is lost. In a desktop, it's often inside the components. and the components, because the components have all the attributes, and somewhere here we have components values. So here we see a div, and this div is consuming or you just follow the memory here on the right side. You have the retained heap. The auxiliary info contains the attributes map, and the attributes, this is not very case specific, contains the composer at some point. I think there's a hash node. This org simple scope. No. I'm somewhat lost. I think I found this before. Attributes. There's simple scope. Maybe here. Not here. Yeah, here it is. Okay. So inside the attributes map, somehow in some stages the retained heap size doesn't show anything. So there must be some optimization inside Java that hides or that it doesn't stop the memory, the garbage collector from cleaning up. But here we see it's the composer that is associated with this class. You can always go from a different perspective in these kind of memory dumps and just see where is most of the memory used. I think the what is it called? The Eclipse memory analyzer has a better starting point. So I just open this one for a sec. In a second, I hope I find it. This divres memory analyzer tool and start it. I hope it doesn't overwhelm my PC. Oh, I'm running out of time. So quickly look into this one. Profiling. What you do is you just say acquire heap dump, specify which application you want to take it from. In this case, it's my Jetty runner, also easy to find, and just take my heap dump. Takes a while. Then it asks me what to report on. I always use the first one, and then it tells me already something. There's a session. Now it tells me the main suspect are a session. Now it's always a session, and inside the session there will be some objects that contain larger objects. And here it's in the end zip file source class web resource. No, this is the session. And we go into details, and then it tells you a lot about this session. And in the end, it even tells me here the high memory composer has a 10 megabyte array of byte array. So that's easy way to find where most of the memory is spent. So memory analyzer and heap profile. So it's, I think we have seen enough of the tools. Let's go a bit through some tips. Where's my IntelliJ here? Or maybe I think we have to make another session because I had two specific questions for this scenario. Let's just go through a few resources. So yeah, okay. So what to do about the performance issues? So one problem was, I would like to demonstrate it, but it's not enough time, is a current memory leak issue with Chrome browser regarding desktops. So if you're using an older ZK version, Chrome doesn't let Chrome blocks the code in ZK to clean up desktops from being sent to the server. So whenever you close a browser tab in an old ZK version, I think before 8.62, I think is the fix, Chrome cannot clean up the desktop anymore, and the request to remove the server-side memory for the desktop is not being sent. So very important one. I already had a few customers reporting this one. That's why I chose to mention it now to a larger audience. If you have, or if you perceive memory issues in Chrome, I think it's since a few months already, this is most likely the cause. And before profiling anything else, be sure to fix this. It was to upgrade, I mean. And this was since, I think, version 72, 73, Chrome decided to block AJAX requests from an on before unload handler on the page, technical stuff. And instead, they had a new API to send a beacon. I call it send beacon. It does the same thing technically. It sends some data to the server, just has less, or it doesn't allow you to read the response anymore. You can just send some data out, but you can't wait for the response. Okay, works. We just need to send this information to the server to clean up the desktop, and now it works again. Now there's a larger list of performance tips, which I think I don't have the time to go through, unfortunately. So maybe next time. Even though this session is called performance tips, I would like to go through all the list and tell when to use which of these things, but it's not enough time. So I will just quickly mention when performance is a critical thing for your application, consider the Java only approach, because anytime that is I think you can still do MVC coding in Richlet, but MVC often stands for using a Zool file and a composer. And MVVM is for Zool file with a view model. And the Richlet approach is direct creation of objects, of components. So if you need the most control and the highest performance, use Richlet. If you need something in the middle, yeah, it's MVC. And if you need a nicer programming model, then use MVVM. But MVVM has some cost because the bindings or the attribute bindings, property bindings, and command bindings, they take up memory, and this is quite significant. I think I will show this in one of the questions I had from Carl or Stefan. Oh, I see a question. Which other tools could help us to improve performance in our applications? Improve performance, I haven't come to this a lot. What to do about it is, biggest tip is don't render too much on a page. And in order to identify what is too much, you have to first profile and figure out what is the problem. One commercial tool I think is called Your Kit. Or similar, I don't know if I spell it correctly, but this is a commercial profiler which I had the chance to use a few times in the past, and it was quite good, not as clunky as the JVisual VM, and it worked well on a larger environment. And then there are the big expensive tools like Dynatrace. I haven't used this. I just read about it or saw a presentation. It sounds amazing if this is true what they claim, because they help you trace everything in your application down to the method level, but also on the larger level in between servers. It's quite, I think, a heavy tool, but it gives a lot of insight, and it somehow is dynamic. It seems to provide less detail where it's not necessary and more detail where there are the hotspots. So it seems to dynamically change the detail of reporting. That's what I got from the marketing talk. I haven't used it, so can't say a lot. Then something very practical in a Zool file. If you have a Zool file, prefer static expressions over data bindings. And if you need data bindings, use init if you only need to bind something once, because the load and the bind expressions are really, I would say, memory heavy, or comparing to the others, because the static expressions evaluate once and disappear from memory. The init bindings remain in memory, but they also evaluate once, and they will reevaluate if you maybe detach and reattach the component somewhere, which is something you rarely do. So very often you can just use static expressions. And the load bindings, of course, they will constantly listen for notified changes and then reapply the changes. If you need this, of course, you have to use it, but if you don't need it, prefer static EL, which is, where can I do this? Yeah, it's in the binding cost. I would like to show a second, because I have this example about binding. I'll just show it for a second. So what this looks like is, here's an init binding, and I would like to show how to compare the init binding to a static binding, for example, which doesn't evaluate. and also the path length of a binding expression or of an EL expression matters. So if you have a short path, it evaluates faster than a longer path. And of course, everything that happens in Java code is faster than in these bindings, because the bindings are interpreted as an AST and they are evaluated dynamically with reflection. This is always slower than Java code. So if you have a chance, move complicated logic into Java code. So this is definitely something you can do because we are Java developers. We know how to write Java code. So whatever you don't have to put into expressions like this or that is faster on the Java side. And then another tip is when you have ZKEE, and this was one question of, I don't know, Stefan or Carl, I forgot. Yeah, how does the render on demand behave? And this is something I can demonstrate live, at least at the client side. I think we don't have time to look at the memory footprint, but you have to trust me if I say something about it. So they have the list box ROD. So this is the ZKEE case with render on demand enabled. Oh, I just disable it for now. Okay, reload. So what we have is this list with 5,000 items. Now we can scroll down and it's rendering 5,000 items. What we can see in the initial response is what ZK does by default in all the editions CE and PE. The initial response contains network, reload. The initial response contains all the elements that are being rendered. And here we can see it's rendering, you see item 0, item 1, item 2, item 3. It goes down to around item 50, if I'm not wrong. 50. Yeah, it goes to item 59. And after this, it renders empty list items and list cells. That's why you will see when I'm scrolling down, you see empty list boxes that fill up over time. And I load it dynamically via JavaScript. So here you see it's rendering from 200 until down to 249. So the next 50 items. So this is what ZK does by default, but it creates 5,000 list items. And if you enable the render on demand, the listbox render on demand feature, it will do something different. It will initially render the same 50 items. And if we scroll down, you see it's loading slightly different. And what we see here is it's also loading sections of elements, 291, so around, I don't know, 100. I don't know why it's 108. It depends a bit on the size of the screen, and it's determining how many items rendering below and above the current visible area to provide some kind of useful scrolling behavior, which you can somehow fine tune with the preload size and the initial ROD size properties. So there are a few things to adjust this. But on the memory side, it means it will only keep these 100 list items in memory and not all the 5,000, even if the contents are not fully rendered. And if you then scroll back up to the top, it has to re-render these items whenever you scroll back up. So this is a way to limit the memory on the server side. And this is ideal for larger lists because you can't render 5 million items, for example. That doesn't make sense. It just gets way too slow. And in this case, you can only render a small window of items. Some people don't like the white screen in the middle. Yeah, if something is loading, that's why we added this loading animation when it takes a bit of time, so you get some feedback that something is being loaded. But it's a trade-off of rendering everything at once, having full visibility of every item when scrolling, or rendering and saving memory, rendering on demand and saving memory in performance. Of course, or use paging if your customers accept this, yes. But very often I hear this is a critical requirement to be able to scroll everywhere. So it's not always possible to convince customers to use paging, unfortunately. I would also say no one needs 5,000 or 10,000 items in a list, but some people think they need it. And that's the trade-off you can do in ZK. Then the other cost, the question was about the binding cost again. If I already mentioned that these bindings with the @ sign are more expensive because these are annotations. Annotations are stored in a hash map at the component at component level, and this hash map is somehow doubly nested. It's quite deep because there can be an arbitrary number of how to call these of these kind of annotations, and each annotation can have an arbitrary number of properties inside the annotation. So this is a two-level nested hash map. So for each init or load, you need a two-level. Is the DOM creation response time improved? I already showed you one example where something was improved, so I can say yes. But in general, it's the same as before. As always, if you create less DOM, it takes less time to create. And if there is a performance issue, we need to trace it down and figure out where the DOM, where we think time is wasted. As in the other example, where there's lots of reflows. Whenever we see a long list of reflows, that's most likely the problem. Otherwise, I don't know of any DOM creation, because DOM creation is handled by the browser. I think we can't change the browser. We can only avoid creating more DOM elements than necessary and avoid restyling when necessary or when unnecessary. Well, we're coming back to this example. I said the annotations are expensive, so if you can avoid them, don't use them. And in this particular case, the question was, is it better to call a method with an this is for a group box, to determine whether or not a group box for a specific component is open or not. And the question was, is it better to call a method with a parameter to determine whether it's open, or to call a hash map with a key? And I don't really know which of the two is better. I would say both are bad. And instead, I would use something I call a row level object. Whenever you have a list of stuff you iterate over, just as said, put the complicated calculation into the Java code and have just a flag. And this is the fastest way to execute. And you have more control to notify change if you need a load binding here, because then you can notify the instance and the property to reevaluate. But for init, if you have init, then I would say use a static binding instead, because init doesn't reload anyway. This is even faster. And to reduce the length of the expression, I would say invert the collapsed and just call it open. And this would be my recommendation for this case. If you want to determine something being open, that's the fastest way. Create an object with a getter, and the getter can have the information. And in the view model, this looks like this. You just create some kind of component or row info object for your UI, and put all the getters you need. The benefit here is you can also add a title to it. You can add other states, read only, not read only, all kinds of flags and information you need to render this specific part of the UI. Because what we do is we render a group box, and maybe the group box has more properties. Could be style information that needs to be loaded. And in this case, if you have lots of these expressions, use static EL based on the object directly. This is the most memory conserving and fastest way to evaluate. I think this question was from Carl. I hope this answers the question. I wasn't able to get significant amount of performance profiling for this, whether or not one takes 10 or 20 milliseconds longer than the other one.
No, it's answered my question. Thanks.
On the migration.
Okay.
What do you mean?
No, it's on-set migration. It's perfect.
Okay, so
That's thanks.
these kind of row-level objects is very often something I consider or make. If you have Java beans that you can't, where you can't add getters and setters to because they're domain-specific objects, I always wrap them inside another object, and this one object is usually more efficient than lots of expressions everywhere. Because an object is an object in Java, it takes a certain amount of space, and an expression or a parsed expression is usually more expensive than a simple object with a few fields and getters and setters. And then you can have a field original object inside this inside this. If you have an original object coming from your database or entities, have a private original object, something like this. Oops. Okay, so that's my suggestion here. Okay, then yeah, as always, I run out of time. I think we have to postpone this for next time. I hope you're still interested in all the other performance killers and the features that are available in ZK. I tend to be talking too long about tools and stuff. I hope it's all still useful. Yeah, once you know where the problem is, then the different solutions make more sense. Yeah, whether it's some client-side rendering because HBox, VBox is slower, or some HFlex, VFlex is causing client-side rendering slowdown, or whether it's a server-side asynchronous task that maybe can be handled better with an asynchronous server push. There's a large range of performance enhancements or to improve the perceived performance. So I will provide this file anyway. If someone's interested in the code, I'll provide some information. And yeah, let's have a part 2 very soon. As it was a private message. So let's try to have it soon. Give us some feedback when is a good time, and then we continue with the consequences of what we just found. We have to waste our Corona time. Yes. Okay. Yeah. Let's keep you busy. Idea change. Oh, thanks for the link. That's because it just makes me crazy that my automatic changes don't work anymore. I hope I find this. Thanks a lot. So always good to get some information back. I didn't miss any of my examples. No. Then, yeah. See you next time. I will stop the recording. And if you have something to say in the comment in the chat, I will leave it open for a few minutes. And yeah, send us an email, reply to your invitation email to get the recording.